Okay, so let us talk about the fourth example. This time the Boolean function is a function of x, y, z that maps to y bar times x bar z plus x z bar. So as usual, we're going to build our table. So atomic variables are x, y, and z. And as I see, I will need y bar. I will need x bar. Once I have x bar, I will multiply x bar with z. I will need z bar and multiply x with it to get x z bar. Then I would like to have x bar z plus x z bar, and finally multiply y bar with x bar z plus x z bar. So we're going to create the table first and then put the truth values in. So remember, we will have 4 t's. Actually, should be writing 1 and 0s. So 4 1s followed by 4 0 for x, and then 2 1s followed by 2 0s for y, and then alternate 1 and 0 for z. Okay. Okay, so when I'm finding y bar, I should get 0 0 1 1, 0 0 1 1. Then x bar should be 4 zeros followed by 4 1s. X bar z, again remember you are multiplying, at least one of the column entry being 0 will make the product 0. So clearly for the first 4 rows, I'm going to get 0 because x bar is 0 in all of them. Then x bar is always 1, so we just look at z. So in the 5th row, I get 1. In the 6th row, I get 0. In the 7th row, I get 1. In the 8th row, I get 0. Z bar is the alternation between 0 and 1. And then you are supposed to multiply it with x. In the first 4 row, x is always 1. But z bar being 0, I get 0. Z bar being 1, I get 1. Z bar 0, so 0, Z bar 1, so 1. But row 5th, 6th, 7th, 8th, x is always 0. So it doesn't matter what Z bar is, your entry for x Z bar is going to be 0. Now you will add x bar Z and x Z bar. As long as I have one entry 1, I should get 1. So the first one is 0. The second one should be 1, 0, 1, and this one should be 1 again because my x bar z is 1. Then I have 0, 1, 0, and I think I deleted them for some reason. So this is what I'm looking at. And finally, with this column, I'm going to multiply the values for y bar. So this and this, they are getting multiplied. As long as you see 0 in as one of the entry, just put 0 in there. So this is also 0. This one is 0. This one is going to be 1. Now this one is 0. That is 0, 1, and 0. And that should be my final column for the truth values of the Boolean function that is defined as y bar times x bar z plus x z bar. Now I can check my work that we have been doing for the last 3 problems. Using the entries for x, y, z, we can check our work is right or wrong. And I'm going to leave that much of the work to you and proceed to our next example. In the next example, we're defining the BGO plus operation. The Boolean operator O plus called XOR and is defined by when I add the same entry of truth values, for example 1 and 1 and 0, I get 0. If the entries differ, so 1 big O plus 0 and 0 big O plus 1 is going to give me 1. Using that, simplify these expressions. So x is an arbitrary Boolean variable. I want to know what is x XOR 0. Remember, a Boolean variable can only take two values, 1 or 0. So the thing we will do, we will say x, and then we will say x XOR 0. X can either be 1 or 0. And now remember, 1 XOR 0 is 1, whereas 0 XOR 0 is 0. That answers the first question for us. Now we will go ahead to number 2, example B. Again, in example B, we are asked to find the XOR values for x XOR 1. So again, write down 1 and 0 for x, and you are evaluating x XOR 1. So 1 XOR 1 is 0, 0 XOR 1 is 1, and we're done. And we will do the third one now. This one is x XOR x. So x XOR x. X can be 1 or 0. 1 XOR 1 is 0. 0 XOR 0 is 0. And the final one is x XOR, that should be x XOR x bar. It's a typo. So x XOR x bar is what we're trying to find out. So we'll do it. Write x and x XOR x bar. And then put 1 and 0 for x. Now, if x is 1 and you want to write down the complement of that, you should get x bar as 0. And if x is 0, then x bar is 1. So 1 XOR 0 is 1. 0 XOR 1 is 1. So the truth table is only once. And that answers our question. And that also concludes the discussion about the introduction to Boolean function and Boolean algebra. In our next module, we will talk about generalized abstract Boolean algebras and dual of a Boolean function.